Hello, everyone. Let's look at just about as easy an example as we can get with factoring a trinomial. Now, what I do is I like to call this an even degree trinomial, right? So we have the highest exponent here is a 2, so the degree here is 2, okay? Then we have this, I call this the middle term, and then we have this term, which we call, or I like to call the floating constant. So an even degree, three-termed expression if we're going to factor this. Okay, first things first. Okay, we always want to look for the greatest common factor. That's right off the bat. Okay, and a lot of people forget about that when it comes to factoring. So the first thing you want to look at is all three of these terms. Do they have any common factors? And this has only two x's. This is if you broke this down, it's really a 3 times 5 times x if we did the prime factorization. So this is x times x, okay? And then 56 is 8 times 7, right? So the prime factorization of 56 is 2 times 2 times 2 times 7. And if you look at all of these factored forms of these three terms, they have nothing in common. So there is no greatest common factor to start with. Okay, now we've talked about, and there are other videos on the box method for factoring. We don't have a leading coefficient here, okay? But when I talk about factoring with my classes, what I usually say is that nobody's really bad at factoring, but people give up too easily, right? Because it's really just a series of guessing and checking. Now, the box method takes away some of that guessing and checking, but it takes a long time to do it. We're going to bypass that for a second. I've got other videos on the box method, which I can point you to if you want to see those. But when it comes to factoring an even degree trinomial that has no greatest common factor, and the exponent of this middle term is exactly half of this, right? This is really x to the first. This is x squared. So this is half of that, and we have a floating constant. There's potential for this to be factored into two binomials. Now, a few things. Whatever this first term is, whatever the highest exponential term is in this expression, okay, that term has to be the product of what we put in these two spaces for these binomials. Okay, so in this case, it has to be x and x. I'm going to do another video here in a second that has a prime leading coefficient. We'll talk about that when we need to. But the values that go here and here have to multiply to be this term, okay? Here's a different way to think about it, all right? The variable, because a lot of times these are going to be variable expressions, the variable that goes in this space has to match the variable of the middle term. So because this is x to the first, these both have to be x's. Okay, there will be another video again where this is a 4, this is a 2, and this is a floating constant. Because this is x squared in that example, x squareds have to go here. Because x squared times x squared would be x to the fourth. But since this is just a quadratic, we're going to leave it like this. So again, these have to multiply to be this term, and the variables that are in these spaces match the variable of what I'm calling the middle term. Now, after that, the numbers that go in these two spaces have to multiply to be this. Okay, now 56 has a limited number of factors, right? We've got 1 and 56, we've got 2 and 28, we've got 4 and 14, and then we've got 7 and 8, and I believe that's it. I believe that's the entire list, right? So what's important after this is you look at the signs. This is positive, okay? So in other words, these numbers that go here have to be multiplied together to get a positive number. Now, that could be two positive numbers. It could also be two negative numbers, okay? Because -1 times -56 is positive 56 as well, right? So because this is positive and this is negative, here's where we know which of these we're going to be using. So we have these lists. And this is what I mean when I say nobody's really bad at factoring. They just give up too easily, okay? Because the two numbers that are going to go in these two spaces have to come from this list. So if you create this list of factors, if you take the time to do this, you're going to be able to factor this expression. You just got to guess and check your way through it. But there's a couple of things we can think about. Okay, so the numbers that multiply to be positive 56, all of those are here. But that's what we haven't talked about, this 15, this negative 15. The numbers have to add to be negative 15. Okay, so when you look over here, none of these positive pairs are going to add together to be negative 15, right? So now we're looking over here, and now we've started to whittle this down. Which two numbers, which pair in this list add together to be negative 15? And that would be these two numbers here. Okay, and in no particular order, we can put the negative 8 there and the negative 7 here. So it's really just a matter of coming up with that list of numbers that multiply to be 56, positive 56, right? Here's everything, the positive pairs and the negative pairs. But then these numbers have to add to be negative 15. And it's just really finding that right combination. Okay, so it's not being bad at factoring, it's giving up too easily. Some people can do this in their head, right? People that are very quote unquote good at factoring have good mental math skills. If you don't have good mental math skills, take your time, do it right.